Local scientists have made an exciting discovery on the seafloor along the Cascadia Subduction Zone.
That's the same zone that could someday give Western Washington the big one, a 9.0 earthquake.
It's been 324 years since the last major Cascadia Subduction Zone earthquake. A lot has changed since then, including the millions of yearly visitors and thousands who call the Washington coast home.
Deep beneath the Pacific Northwest is a silent danger called the Cascadia Subduction Zone. This massive fault has been strangely quiet for centuries.
One of the biggest earthquakes in history. Culprit behind all this misery? Well, that would be the Cascadia Megathrust Fault, an offshore subduction zone.
But scientists have just warned that this fault is dangerously overdue for a catastrophic quake. It is so bad that the fault is capable of reaching a magnitude of 9.0 and triggering tsunamis that could obliterate coastal cities like Seattle, Portland, and Vancouver. Over 300 years ago, the last massive eruption left scars still visible today.
The bright blue Pacific crashing along the beaches. But what's underneath still shows evidence of the Great Cascadia earthquake that happened more than 300 years ago.
So are we on the brink of witnessing one of Earth's most violent natural disasters? Join us as we reveal the terrifying truths and urgent warnings surrounding this geological time bomb. The silent danger beneath the Pacific Northwest. Now, you may not know, but the Cascadia Subduction Zone is where two massive tectonic plates, the Juan de Fuca plate and the North American plate, collide. These plates constantly move, but instead of sliding smoothly past each other, they've locked together, creating unimaginable pressure.
Plates that make up the ocean floor are stuck, locked to the North American plate that makes up Washington. When the pressure becomes too great, those plates slip, forcing the ocean plate.
One day, all this pressure will be released in a devastating earthquake, potentially one of the largest ever recorded. This isn't just a theory. Scientists have discovered evidence of past megaquakes caused by the Cascadia Fault. In 1700, the last one was so powerful it sent massive waves, or tsunamis, racing across the Pacific Ocean to Japan. This wasn't just any earthquake. It had a magnitude of 9.0, the kind that can destroy entire regions. But what's truly chilling is that this fault hasn't moved significantly since then. It's like a time bomb, silently building pressure each day. So what happens next? Come closer, because this is where it gets even more interesting. You may be wondering how we know about these ancient earthquakes. Scientists have become detectives, piecing together clues from the land and sea.
A new study by the University of Washington has uncovered liquids seeping from the seafloor about 50 miles off the coast of Oregon. Researchers hope this underwater spring could offer up some clues to potential earthquake hazards.
Along the coasts of Oregon, Washington, and British Columbia, they've found layers of sand buried beneath the earth. These sand layers are remnants of ancient tsunamis, giant waves that swept the land after a massive earthquake. But it's not just the sand. Indigenous communities in the Pacific Northwest have long told stories about the ground shaking violently and the ocean swallowing the land. These oral histories align perfectly with the scientific evidence of the 1700 earthquake. Together, science and ancient stories paint a terrifying picture of Cascadia's past and potential future. And unlike some faults that produce smaller, frequent earthquakes, Cascadia is quiet, almost too calm. This silence isn't anything good, it's alarming. It means the fault is storing more and more energy. When it finally breaks, the earthquake will shake the ground for minutes, not seconds. Think of entire cities trembling, roads cracking, and buildings collapsing. This isn't just speculation. This is what experts are preparing for. Adding to the danger is that many people in the region are unaware of the risk. While places like California are well known for earthquakes,
geologists are out with a very startling warning that Southern California is overdue for a major and possibly catastrophic earthquake.
the Pacific Northwest has a false sense of security, but history tells us that Cascadia is capable of destruction far beyond what most of us can imagine. But why hasn't the fault moved for so long? The answer is in how these plates interact. The Juan de Fuca plate slowly dives beneath the North American plate, a process called subduction. As it pushes down, it drags the edge of the North American plate with it. Over centuries, This has created immense pressure. The fault will rupture violently when that pressure finally overcomes the friction holding the plates together. Scientists have also discovered that parts of the fault experience silent slip events.
This study towards identifying the relationship and interaction between some small slips, small earthquakes, and how they may relate to some even bigger earthquakes, including quakes on the Cascadia Subduction Zone,
where the plates move without causing earthquakes. These slips might seem harmless, but some believe they could trigger a major quake. It's like the fault is whispering before it finally screams. But you would be shocked if we told you that the Cascadia Subduction Zone doesn't just threaten the Pacific Northwest. It's a global issue. Yes, we made no mistake when we said that. A magnitude 9.0 earthquake would affect millions, damaging homes, businesses, and infrastructure. The shaking alone could last up to 5 minutes, longer than most of us can imagine. But the earthquake is just the beginning. A quake this size would trigger a massive tsunami, with waves towering as high as 100 feet. These waves would crash into the coastline within 15 to 30 minutes, leaving little time to escape. Entire towns along the coast could be wiped out. The damage wouldn't stop there. Supply chains would be disrupted, power grids would fail, and recovery could take decades. But what if we tell you that the Cascadia Subduction Zone isn't just a threat to massive earthquakes alone? It's also the force behind some of North America's most iconic and dangerous volcanoes. Can you believe that? Let's find out more. The volcano connection. It is no news that the Pacific Northwest is home to breathtaking coastlines and towering mountains, but beneath this beauty lies a ticking time bomb. We have towering mounts across this region, like Mount St. Helens, Mount Rainier, and Mount Hood. But these volcanoes owe their fiery existence to the same tectonic forces that could one day unleash the big one. Undoubtedly, the Cascadia Subduction Zone, in a way, fuels both the quakes that shake the ground and the eruptions that fill the skies with ash and fire. These natural disasters would strike quickly and without mercy, changing the region's grounds and risking millions of lives. One of the most dramatic examples of this connection happened in the 1980 when Mount St. Helens erupted with terrifying power. The eruption blasted off the mountain's top.
At 8:32 a.m., Mount St. Helens erupted.
They are calling it the most violent eruption of this volcano in 32,000 years,
sending ash and rock hurtling miles into the sky. The eruption wasn't just a random event, but directly tied to the subduction zone's relentless underground activity. Scientists now believe earthquakes along these faults can sometimes trigger volcanic eruptions or give them a nudge. But Mount St. Helens isn't the only threat. Nearby, Mount Rainier looms as a quiet giant. Unlike Mount St. Helens, it hasn't erupted in recent history, but experts warn it's far from dormant. As if that is not enough, Rainier's icy slopes hide another danger: lahars. This lahar is known to be a destructive volcanic mudflow created when hot volcanic material mixes with water. This water can come from melted glaciers, heavy rain, or even rivers disrupted by an eruption. The result is a fast-moving river of mud and debris that can travel 40 miles per hour. These deadly mud flows can rush down the mountain at terrifying speeds, destroying everything in their path. Scientists warn that a lahar from Rainier could bury nearby towns like Ording, Washington, under 30 feet of mud within an hour. It's not just the speed of a lahar that's deadly, it's also its weight and power. Lahars can carry boulders the size of cars and flatten forests as they roar down valleys. So if Rainier erupts, the combination of fire, ash, and mud could spell disaster for nearby towns. But have you thought of what would happen if the Cascadia finally unleashes its fury? Terrifyingly, when the Cascadia Subduction Zone finally ruptures, the earthquake won't just shake the ground, it will also unleash a massive tsunami. Scientists estimate a 1 in 3 chance of a magnitude 8.0 to 9.0 earthquake striking within the next 50 years. That might sound like a gamble.
It sits on unstable soil that could liquefy in a Cascadia earthquake with a magnitude 8 to 9.
But it's a scary reality for the millions living in this region. And here's how it happens. When the tectonic plates along the fault line slip, They release a burst of energy so powerful that it pushes the ocean above them, creating a series of towering waves. These waves, known as tsunamis, can travel up to 500 miles per hour. Think of a wall of water taller than a 5-story building racing toward the shore. This is the terrifying reality scientists have modeled for Cascadia. The tsunami would strike within minutes of the earthquake, leaving coastal communities with almost no time to evacuate. Cities like Seaside, Oregon, and Crescent City, California, could be wiped out instantly. The force of the water would destroy homes, sweep away cars, and uproot trees. Moreover, the tsunami would travel inland, flooding areas far from the coast and causing billions of dollars in damage. But that's not all, because while tsunamis threaten coastal towns, lahars pose a different danger for communities near the Cascade volcanoes. The scariest part of these disasters is how they are connected. A single Cascadia earthquake could trigger both a tsunami and volcanic activity, leading to lahars. For example, if the quake destabilizes the volcanic structures of Mount St. Helens or Mount Hood, it could cause an eruption. This eruption, in turn, could unleash a lahar, doubling the devastation. Coastal towns would face tsunamis, while inland communities would be at risk from mudflows. The scale of destruction would be unimaginable. So is there any form of preparation against the impending danger? Are we ready for what's about to come? How are we preparing? The good news is that scientists, governments, and communities are working hard to prepare for these threats. Early warning systems like the Shake Alert are designed to detect earthquakes seconds before the shaking starts. This system could send alerts to people's phones, giving them precious moments to take cover or evacuate.
Earthquake. Earthquake.
Oh my god, bitch. I gotta go outside.
Earthquake.
Sometimes these warnings could give people 30 seconds to several minutes to act before the worst shaking begins. It's not much time, but it's enough to save lives. For tsunamis, warning sirens have been installed along many coastlines to alert residents to reach higher ground. In some areas, towns have built vertical evacuation structures and tall, reinforced buildings where people can climb to safety during a tsunami. Coastal schools and communities conduct regular tsunami drills to teach people how to respond quickly. These efforts are critical because every second counts in a real disaster. Scientists use GPS sensors and seismic monitors to detect ground movements near volcanoes for lahars. If a lahar starts, warning systems can alert residents in its path. Towns like Ording, Washington, have evacuation routes marked with signs directing people to higher ground. These paths are designed to quickly get people out of danger, but experts stress that early warnings are key. So while the Cascadia Fault and its volcanic neighbors may seem unpredictable, scientists are working tirelessly to detect even the smallest movements deep within the Earth and giving us a fighting chance. These movements can sometimes tell that an earthquake or eruption is about to happen. For example, scientists track a phenomenon called ground deformation. This occurs when magma starts rising toward the surface, causing the ground to bulge slightly. This swelling can act as an early warning sign of volcanic activity. Similarly, small, frequent earthquakes called tremors often occur before an eruption, like a volcano's version of a heartbeat, but predicting earthquakes is much harder. Unlike volcanoes, earthquakes don't always give clear warnings. The Cascadia Subduction Zone is especially tricky because it's so quiet most of the time, but the scientists have identified patterns of slow movements, known as slow slip events.
Seismologists say in the next month we are due for a major event that apparently no one will feel. It's called a slow slip. And we talk with the Pacific Northwest Seismic Network about how they work.
Where the plates shift without causing large quakes. These events might be subtle clues that pressure is building. Sadly, despite all these precautions, many communities remain unprepared. In coastal towns, older buildings are not built to withstand tsunamis. Some residents may not have access to evacuation routes or may not know how to respond. Public education campaigns are trying to change this, teaching people the importance of readiness. For example, 2011, when a tsunami struck Japan after a 9.0 earthquake, many lives were saved because residents knew to head for higher ground immediately. The same level of preparedness could save thousands of lives in Cascadia. It is, however, important to note that no amount of preparation can completely eliminate the dangers of a Cascadia earthquake, tsunami, or lahar. Even with advanced technology, predicting the exact moment of the disaster remains a challenge, which is why experts have instead focused on preparation. Communities near volcanoes and along the Cascadia Fault have started building better infrastructure, creating evacuation plans, and educating the public about what to do when disaster strikes. So the steps being taken, like early warning systems, reinforced buildings, and public education, can reduce the loss of life. The region faces an enormous challenge, but with continued effort, it can better handle whatever comes next. So undoubtedly, without preparation, the consequences of a Cascadia megaquake would be unthinkable. Roads would crumble, power grids would fail, and communities could be cut off for weeks. But with the right measures, we can reduce the damage and save countless lives. The odds may seem distant, but the danger is very real. The Pacific Northwest is racing against time to prepare for the big one. The question we should all ask is, are we ready? Let's hope the answer is yes, because when the Earth shakes, every second will count, and it is no longer a question of if these disasters will happen, but when. We've come to the end of this video. These tools are placed all across the fault region and will detect the minutest of seismic waves. The results obtained from the seismographs help them determine the magnitude, depth, and location of earthquakes. It also helps them to determine how fast the plates are moving. Thanks to this research method, the scientists now know that the movement of the San Andreas Fault is not patterned. What this means is that the movement of the plates differs from area to area. The plates smoothly slide past themselves in certain areas. This type of movement is what causes the small earthquakes that happen from time to time. This movement pattern has been termed creep. In some other areas, there is no creeping pattern because the fault is held in place. Since the plates in these areas are locked together, the stress and pressure are not relieved the moment they begin to build. Instead, they accumulate, leading to a very large earthquake. As we said, these scientists also study past earthquakes that occurred on or near the San Andreas Fault. To give them more accurate information, they study the sediment and rock layers that are found along the San Andreas Fault. They hope to learn how to identify previous earthquakes and determine their frequency and magnitude. Paleoseismology is the name of this study of earthquakes. This study has helped researchers determine that the massive earthquakes that happen on the fault happen at different intervals. In some cases, these earthquakes occur several hundreds of years apart. Furthermore, these researchers do not only study the fault, but they also study the impact of seismic waves on buildings and other infrastructure. The information they get from this research aspect is proving invaluable for building engineers. With this information, engineers can design and build structures capable of withstanding massive earthquakes. As a result, private individuals and the government can minimize the damage to buildings. Furthermore, applying such information to building constructions can save the lives of people who would have been buried under the rubble of buildings that cannot withstand earthquakes. If such an earthquake happens as predicted, it will have devastating effects on nearby regions. Let's discuss this in detail in the next chapter. Devastating impact of a major earthquake. A major earthquake on the San Andreas Fault would greatly impact the nearby regions. Because of the condition and location of the critical crack, any resulting major earthquake will impact a wide area, including cities that are densely populated. According to the data collected, the regions that are within the radius of the earthquake's epicenter will experience severe shaking that could lead to death and damage to buildings. Scientists state that the San Andreas Fault is close to eruption. Eruption, in this case, does not mean there is a volcano underneath San Andreas. Just imagine the doom and destruction that would cause if that were the case. Instead, the eruption is a geological language that refers to the quick release of stress that is built over a long time along a fault line. The release of this stress energy is what makes the ground shake, which we describe as an earthquake. In the case of the San Andreas Fault, the tectonic plates on both sides have been sliding over themselves for a while, causing the accumulation of stress. Although the energy is yet to be released, it is at its tipping point and could happen at any time. To mitigate the impact of such an event, scientists are doing all they can to understand the magnitude of such an earthquake. With this understanding, they can reduce its impact. NASA has reported that proper risk assessment relies on several factors. First of all, the amount of accumulated stress is a crucial factor. Given the history of the region and its notable earthquakes, the current accumulated stress points to another earthquake of similar magnitude. Although the scientists at NASA know that the possibility of such an occurrence is very high, they cannot accurately predict when such an eruption will occur. All they can say is that it will happen sooner than later. Another factor these scientists consider when assessing the risk is the magnitude of the potential earthquake. When we talk about magnitude, we are talking about how much energy is released when the crack erupts. The more energy released, the greater the damage of the earthquake. It's also difficult to determine the magnitude before the eruption. So, all these scientists can do is estimate the magnitude using the depth and length of the potential rupture segment of the fault. Looking at the crack that has caused many great concern, NASA reports that this crack is part of a segment that is highly active. With this information, scientists have estimated that if it erupts, it could cause an earthquake of magnitude 7.0 or even higher, which is categorized as major. Such an earthquake can be devastating, causing widespread destruction of the environment, buildings, and general infrastructure. The past notable earthquakes that we talked about earlier give scientists an idea of what they should expect if a magnitude 7.0 earthquake hits the region. Not only does it help them determine the extent of the devastation, but it also provides insights into the behavior of the fault. The scientists combine historical and current evidence to estimate how often such major earthquakes occur along the San Andreas Fault. Based on research findings, we're reaching the beginning of a new interval, which is usually marked by a major earthquake. Which cities and areas will be affected by this earthquake? According to the simulations and predictions run by NASA and other research centers, areas near the southern segment of the fault, such as Los Angeles and San Diego, would experience severe shaking that could cause serious damage to roads, buildings, and infrastructure. Cities could be swallowed by the earth, leading to massive loss of life and property. Because of the high population in the Los Angeles metropolitan area and the extensive infrastructure it boasts, this area will be greatly affected. With a major earthquake, emergency services and transportation utilities will be disrupted. As a result of this disruption, residents would find it hard to get these essential services. Although the fault's central segment is located underneath less populated regions, the risk to the smaller communities and towns in the region is still great. Examples of towns and communities that would be affected include the Inland Empire and the Coachella Valley. These areas might experience moderate to serious shaking when the earthquake hits. The agricultural sector is an important sector that might suffer serious damage because of the earthquake, and Central California will bear the brunt of this impact. Irrigation systems, farming activities, and general food products will be disrupted. The effect will not only be felt within the immediate region, it will affect the general food supply chain. San Francisco Bay Area is on the northern segment of the San Andreas Fault. Due to its history of earthquakes, another earthquake would affect major urban centers like San Francisco, San Jose, and Oakland. These centers will experience severe shaking and possible liquefaction as the ground itself becomes more liquid than solid because of how severe the shaking is. In turn, roads will crack and buildings will collapse, which will pose huge risks to people. The coastal areas that the fault line runs through are not exempted from the widespread destruction. These areas are bound to experience primary shaking just like other areas. In addition to the shaking, residents should expect secondary effects such as tsunamis, although they are not common in these regions when you compare the occurrence of the subduction zones. However, scientists do not rule out the possibility of tsunamis in these coastal areas. A full rupture could cause coastal areas to slide into the sea. With the shaking and possible tsunami in the coastal areas, bridges and highways would be damaged. This destruction will bring trade and transportation to a halt. Consequently, the economy will be affected, and this is not just limited to California. the United States of America will feel the negative economic effect. So far, we've been talking about the effect on nearby regions. Does this mean that these areas are the extent of the earthquake's impact? Certainly not. Certain regions that are not within the fault line's immediate vicinity will also feel the impact of the earthquake. Let's use a historical earthquake as an example of what might happen. A Southern California earthquake reverberated in certain areas of Nevada, Arizona, and the northern part of Mexico. Therefore, it is safe to say that an earthquake that hits the San Andreas Fault will affect the entire state of California. Pipelines and highway railroads are the infrastructure that would most likely be affected. The disruption of these transport systems would halt the transportation of goods, thereby causing economic losses. Even emergency response services might be affected by the earthquake as well. Apart from the initial shaking, the aftershocks can have devastating effects as well. A typical example is the Christchurch earthquake that happened in New Zealand in 2011, when an earthquake of magnitude 6.2 struck the area. Since this event, the city and the regions surrounding it have encountered over 10,000 aftershocks. The next chapter focuses on the insights experts have revealed regarding the recent findings. Expert insights regarding the recent findings. Many geology and seismology experts have revealed valuable insights regarding NASA's recent findings and their significance. A reputable seismologist, Dr. Lucy Jones, stressed how important these findings are. She said that the new data from NASA confirms what many scientists have believed and have worried about over the years. The fault is experiencing significant stress, which demands more vigilance and preparation in case of a possible earthquake. NASA's technology provides more accurate information that will help to enhance the current predictive models. A renowned geologist, Dr. Thomas Jordan, also emphasized the value NASA's advanced technologies have provided. He said that because of the INSAR combined with other remote sensing technologies, monitoring the fault is easier and far more accurate than it used to be. He went on to say that these advanced technologies enable scientists to detect the subtle buildup of stress and movements in the fault. Being able to monitor the stress and movements is necessary and crucial for risk assessment. Dr. Jordan finally underscored the importance of investing in advanced technologies such as these. Dr. Kate Hutton was concerned about what these findings meant for the safety of the public. During her interview, she stated that the increased stress and activity at the fault means the focus and priority must be on preparing for such an earthquake. She said that this preparation is not the responsibility of the scientific community alone. Instead, the communities that might be affected must also be prepared. Dr. Emily Williams, a renowned geologist, shared insights on the fault and stress buildup, and her insights corroborated what the other experts had said. She went ahead to speak about the unprecedented nature of the San Andreas Fault, which indicates a stress buildup in the tectonic plates. She revealed that the eruption of the fault can disrupt the natural flow of streams and rivers, and even drainage systems. These disruptions could lead to record-breaking floods that won't just affect the nearby regions, but other geographical areas as well. Due to these warnings, residents in these regions are more alert. However, there is no sign of mass evacuation or planned evacuation by the government. Instead, residents continue to live their daily lives with the knowledge of the risk. Thankfully, NASA has collaborated with several research centers. For instance, NASA is collaborating with the USGS, U.S. Geological Survey, which has been actively studying the fault for several decades. As a result, the USGS has very important data that can be used to develop further research. This does not even take into account the expertise they possess. The USGS and NASA are working together to integrate satellite observations with ground-based measurements. Doing so will create a detailed picture of the fault's behavior. The SCEC, Southern California Earthquake Center, is also studying the fault. More than 60 institutions constitute this center, and they carry out interdisciplinary research on the processes of earthquakes. Some of these research works include the development of computer models to simulate earthquake scenarios and assess the potential impacts. NASA collaborates with the SCEC to enhance these models by providing updates in real time and also improving their accuracy. Caltech, California Institute of Technology, is busy analyzing seismic data and conducting different research projects. NASA scientists have been using the data from these research projects to study the fault's physical properties and the mechanics of earthquake generation. Beyond these organizations, NASA also works with scientists from across the globe. These scientists share their findings and methodologies from fault systems that are similar to the San Andreas Fault from other parts of the world. This process allows NASA to compare the fault behavior of other faults, thereby enhancing global earthquake prediction models. With all this potential destruction hanging in the balance, what is the government doing? The truth is that they are doing a lot already, given that most of these research centers and agencies are owned by the government. So, not only is the government actively researching the fault, but they are also taking steps to improve earthquake preparedness and safety. If you loved this video, kindly like the video. You can also click on the subscribe button to get more interesting videos such as this when we post them.